Alright guys, welcome to RC Mojo. This week we're going to get the gimbal on the TXT1 working properly. We got fairly close with it last time, but I couldn't find a proper pulley belt that fitted, and the rubber bands are not surprisingly very stretchy. To replace those bits, I've got a reinforced tooth belt that's not going to stretch, getting rid of the bounce, and a couple of tooth pulleys, the big one's 40 tooth and the small one's 16. We should end up being able to look almost completely backwards when it's fully turned. The first thing we need to do is remove the plastic tray. We've got two self-tappers at the back that screw into the damper mounts. At the front there's two M3 screws and nuts that fix the tray to a couple of bits of aluminium angle making up the front mounts. Before the tray can fully come out, the ball ends on the bottom of the dampers need to come off too. Then we can just slide it out and disconnect the remaining connectors. Next we can peel the ESC and receiver off. The tray will probably need some trimming on the scroll saw, so we need to remove all the bits. The gimbal's held on with a long M3 screw and nylock nut. We need to keep the screw in position with an Allen key and remove the nylock from the bottom. Then we can remove the screw. The aluminium plate's threaded, so with the nut you can lock the screw and set the gap so we can set up the side load. The screw slides out from the bearings and the old pulley should break off fairly easily. We'll need to clean up the old glue of course before we fit the new pulley. So we can figure out where the servo needs to go, we need to fit the new small tooth pulley to the plate with a long screw. It doesn't need to be tight or all that stable, it just needs to keep the pulley in roughly the right position. If we lay the new belt over the pulleys, it looks like the servo is going to need to move back quite a bit. Unfortunately, there's far too much slack to use an idler to take it up, but moving the servo will keep things nice and simple. It's currently held in with a couple of M2 screws and nuts, and some bits of 2mm plastic to space it off to get the pulleys at the right height. To find the new position, we'll use the big pulley and the belt so we can get an idea of where the servo output wants to be. It only needs to be a rough position, but it's going to be close enough. Looks like we need to extend the hole back around half a servo's width. Should be quite doable, and we'll allow a little bit extra for adjustment. Next we need to modify the big pulley so it'll actually mount up to the servo splines. It's really designed to clamp down to a 1/4 inch rod, so there's a bit of fiddling to be done. In my parts box I found this little widget that just so happens to be a very snug fit inside the pulley. With the excess cut away, it'll make up the first bit of the puzzle. To lock into the splines, we're going to use a bit of a servo arm. With the arms cut off and 4mm of the hole in the pulley drilled to roughly 7mm, it's going to snugly fit inside. Then we get the fun bit. I'll need to trim the ends so they actually interlock. That should be fun with the Dremel. And here we are then. This is the remains of the servo arm with a slot cut in the top, all done freehand with a Dremel. It then interlocks with the black plastic bit that's now inserted in a pulley. It's so tight in there I couldn't get it out. You get the idea though. Because I did it all freehand, the fit isn't quite perfect. So to fill the gaps I'm going to use a little bit of 5-minute epoxy. We just need a little bit around the outside of the hole, and when the servo arm goes in it will spread out, making the engagement slop free. It's worth noting this technique only really works if there isn't much torque involved, or shock. If this was in the steering for instance, the epoxy would crack in no time and it would quickly fall apart. Here's the pulley ready to go. The only other thing I've done is cut the top of the black plastic flush with the pulley, revealing the hole down the centre for the screw. And it just presses onto the servo like any servo arm. Great stuff. Okay, next we can modify the plate so we can actually tension the belt. There's not much to it. I lengthen the hole for the servo towards the rear of the plate. It extends back a bit further than it really needs to, so we can take up extra slack as the belt ages. I made the mounting holes into slots too, so we can freely adjust the servo's position. All we do is refit the plastic spacers, the M2 screws, and pop the pulley on. And here we have the working setup. We can't tension the belt too much as the servo output really isn't strong enough. It's already starting to lean over a little. I think it's going to do the trick though, you'll just have to keep an eye on it. If all else fails, we'll have to swap the servo for something with a bit of a beefier output. If we power it up with a servo tester, we can get an idea what the final throw is going to be like. I've put a little dot on the pulley near where the screw head is. It looks like it's going to be enough that when we look backwards and down we should be able to see the rear tyres. Perfect for seeing what the truck gets hung up on when we get stuck. Next job is to attach the small pulley to the bottom of the gimbal. Technically it's an idler pulley with teeth, so it's not really designed to transfer power. However, just like the servo arm mod, we're not going to be transferring much torque or shock, so we don't need to be all that clever. We just need to clean up the bottom of the gimbal and mark up the pulley's top face. A bit of a rub with a sanding block sorts out the gimbal. It's important that the bottom face is nice and flat. The pulley's been marked up with a Dremel to give the glue something to bite into. And since we're going to be gluing right next to one of the bearings, we need to add a little bit of grease so we don't glue the bearing solid. I'm using some silicone grease as it shouldn't affect the plastic, and it just so happens to be within arm's reach. We only just need enough to coat the bearing. Next, the long screw goes in through the gimbal. We apply a little bit of epoxy near the edge of the pulley, slide it over the screw and gently nip up the nut just to keep it in position while the glue hardens. Now it's 5-minute epoxy, but to make sure nothing's going to move I'm going to leave it for an hour or so. It's always better to be safe than sorry. Right, if we pop the nut off we can see if it's stuck, and well, it seems pretty good. It's nice and straight too. We'll need the nut back on to get the pulley at the right height to match up with the servo. It will also let us set the float for the bearings. We want to lock the nut against the aluminium sheet so there's just a hint of detectable float in the gimbal. Too much and it's going to rattle, and too little it's going to knacker the bearings. It takes a bit of trial and error to get it just so, but it's worth taking the time to set things up like this so the assembly is going to last a long time. When it's set we can add a washer and nylock to the bottom to really make sure it's not going to go anywhere. It's lovely and free spinning, and of course it doesn't wobble at all, so we should get a nice stable picture when we're all finished. We can hook the big pulley back up now with the belt and give it a test with the servo tester. You can really see the extra pan we get with the different size pulleys now. Far more useful than the 45 degrees either way you get with the standard servo mounted gimbal. All that's left to do now is refit everything back to the chassis. We'll need some fresh servo tape for the ESC and receiver, and other than that it's the reverse of the beginning of the video. We plug all the bits in, reinstall the self-tappers at the back, pop the dampers back into the cantilevers and reinstall the front M3 screws and nuts. And that's about it. Quite a bit of effort for something that doesn't really look a lot different to when we started. The good bit though, I think this setup might actually work, which is definitely a good thing. With the radio hooked up, it seems to work a treat. I had to slow the servo movement down a bit more in the transmitter settings. Other than that, and a bit of trim, it's all working rather nicely. We better check the wiring for the camera is going to reach too. It'll need updating at some point as we're still using the camera's internal battery, and that twisted pair for the composite video and ground are far from ideal, especially when they're running right next to the ESC and motor wires, not to mention the fatigue the wires are going to see on the micro USB connector. It'll get us running though, and it looks like, while it's a bit of a rat's nest, it's going to be good enough for a test run. The camera isn't colliding with anything, although we might have to watch out for the cantilevers when we look down and to the rear. And I suppose that means we're going to have to go outside and see how it handles vibration. There's one thing for sure, you get a better idea of the field of view when it's outdoors. The control is fairly smooth considering how much we've geared up the drive from the cheap servo. It's a tiny bit notchy, moving in small steps, but it's quite acceptable. The real test though is to try filming something. So here we have, hiding under the onboard footage, the grand hauler. The goal is to try and film the hauler while driving circuits. It sounds like it should be fairly easy, but trying to steer the TXT1 and move the camera turns out to be rather difficult to coordinate. I think with a little bit of practice, or a lot of practice, or better yet 2 people operating the TXT, one driving it and the other controlling the camera, it's going to make for some neat footage of the scale trucks. The most difficult thing was trying to figure out which way was forwards when the camera was slightly rotated. It really needs some sort of on-screen feedback for the camera direction relative to the chassis. I'll leave the attempted onboard footage rolling until the outro, so that's it from me. You might spot a little board hiding behind the cab on the grand hauler while it's running around. That's the first working prototype of the wireless trailer control transmitter, but more on that in a couple of weeks with any luck. Anyway, thanks for watching, like if you liked, subscribe if you fancy it, and if you've got something on your mind, leave a comment. Bye guys!